for the first column, we have 14 square roots of 5 minus 3 square roots of 5 minus 10 square roots of 5. They all have a common radical of 5, so I can go ahead and combine like terms. So I'm going to say 14 minus 3 is, go ahead, tell me. 11 square roots of 5. And I'm going to bring down my minus 10 square roots of 5. And then go ahead and combine these like terms. If you want to do it all at once, you could do that. But we have 11 minus 10 is 1 square root of 5, or you can just say the square root of 5. Questions on number 1? If they're already like radicals, makes your life easier. Yes, ma'am? So 11 minus 10 would be an understood 1. Okay? No, the answer is 1 square root of 5.
1 square.
Alright, so for number 3, we have 15 square root of 18 minus 3 square root of 50 plus 8 square root of 98. Okay? So we're going to take it piece by piece and simplify first. So I'm going to draw a line right now just to separate my radicals and simplify them first. So I'm going to simplify the square root of 18 so that I have 15 square roots of 9 times 2, because 9 times 2 multiplies to give you 18. 9 is a perfect square, so it comes outside as a 3, and I have to multiply it by the 15. So I end up with 45 square roots of 2. Now I need to go to the middle radical and simplify that one. Okay, so I'm going to have negative 3 square roots of, I'm going to use 25 times 2, because 25 times 2 is 50. 25 is a perfect square, so it comes outside as 5, and I have to multiply it times my negative 3, so that I have negative 15 square roots of 2. Now I need to simplify the last one. I'm going to rewrite it over here so I have some room. 8 square roots of 98. I need to break down 98. What are some factors for 98? Yeah, you know, anybody?
49 times 2.
49 times 2?
That's my whole.
Okay, 49 is a perfect square. So it comes out as 7 times 8. Right? So what's 7 times 8? 56? Square roots of 2. Stop, gentlemen. Now they all have a square root of 2, so I can add and subtract them. So you're going to say 45 minus 15 plus 56.
86.
Yeah.
So number 3 is 86 square roots of 2. Questions?
Number 3.
That's number 3. Alright, let's do one more example. We're going to do number 5. Both. Okay, so I have 5x square root of 99y squared plus 2y square root 44x squared. Okay, so we need to first simplify the first radical. Okay, so I'm going to write my 5x, and I'm going to break up 99 into 33 times 3, and yeah, you could use a 9 and 11, that's fine.
Oh, but 9 is a perfect square though, so we can use it.
Right. So then we're going to break up 33 into 11 times 3 times the original 3, y squared. Here's a pair of 3's, so it's going to come outside, and we have 5x times times 3. This y squared is also going to come out because it's a pair of y's. So I end up at 15xy square roots of 11.
But wait.
Okay? The 3's came out. You had one pair of y's. No, we're not on number 7. 3 times 3. 33. We broke 33. We broke up into 11 times 3. The 3's multiplied and give you 9. The square root of 9 is 3. 3 times 5 is 15. We have one pair of y's. Gentlemen, please stop. If you already know how to do this, then finish the rest of the page. Okay, right. And the 11 came down. So now we need to do the second radical. So we have 2y. We're going to break up 44 into 4 times 11, x squared. 4 is a perfect square, so it comes outside as a 2. Multiplying.
But it's not a go like,
And x squared comes out as an x. So we end up with 4xy. Square roots of 11.
but it's not like y and x are not common.
Right, and it's okay if it's on the outside.
Oh.
We're looking underneath the radical. And this was an addition problem. So now the radical is the same. It does not matter the order that you write the variables. You could say yx, but normally the number comes first and then the variables are alphabetical. Okay, that's normally how you write it. So then we're going to end up at 19xy square root of 11.
That makes sense. Maybe my mind doesn't. It doesn't.
Hold on, let me